Welcome to this video on the UI feedback node in MUSE Automator. The UI feedback node is used to effect feedback changes on a touch panel such as button states, level values, or text fields. For this example, we have created a flow that includes our controller and control panel nodes that are already configured to communicate with our MUSE controller and our touch panel. We will also be using inject nodes to trigger each of the UI feedback nodes for demonstration purposes. In a production system, you would use these UI feedback nodes in conjunction with the logic of your actual program. The first feedback type we will go over is channel feedback. Open the UI feedback node settings in our channel feedback group and see that our control panel has been selected for panel and the type is set to channel. In addition, the touch panel button named channel is selected from our list of buttons and the input method is message payload. Close the UI feedback settings and notice that we have two inject nodes going into this one UI feedback node. The first sends a message with the payload of true, and the second has a payload of false. When we activate the true inject node, you will see the feedback for the button named channel on our touch panel turns on. When we activate the false inject node, you will see the feedback turns off. Next, let's look at the multi-state feedback section. In this example, we have used three separate UI feedback nodes, and each one will manually select a different button state. Open the node settings of the first one, and you will see that we have selected the state type, the button named mState, the input method is manual configuration, and in the state field, we have entered 1. Close the node settings and notice that each of our UI feedback nodes in this section has its own inject node connected to it. Because these nodes use the input method of manual configuration, it does not matter what message payload we are sending to these nodes. Any message they receive will trigger the node to update the feedback to the state we configured. We can now trigger each of the inject nodes in this section, and you will see the feedback on our button named mState update on our touch panel. State 1 of our button is blue, State 2 is red, and State 3 is green. Next, we will look at the level feedback section. When looking at the UI feedback node, we have selected the type of level, selected the level of the main page of our panel, and chosen an input of message payload. We will be using multiple inject nodes configured to send a message payload of various number values to the UI feedback node. As we trigger each of these inject nodes, you will see the bar graph on our touch panel update with the value that we are injecting. The final section we will look at is the text changes section. For this, we will look at both manual configuration and message payload input methods. Open the first UI feedback node in the manual configuration section and see that we have selected a type of text, the button named text on our main page, and the input method of manual configuration. In the state field, we have entered the value of 0 for all states, and in the text field, we have entered a value of Hello World. The second node has the same settings except for the text field has a value of testing 1, 2, 3, 4, 5. We can use the corresponding inject nodes to trigger each of these UI feedback nodes. You will see the button text update to the value that we manually configured in each UI feedback node. Moving down to the message payload section, you will notice that we have a couple of extra nodes. This is because when using the UI feedback node to update text with an input method of message payload, we must use an object to specify both the state and the text to update. The UI feedback node in this section is using the same type and button as our previous example, but the input method is set to message payload. In our example, we have two options on how to accomplish this. We will first look at the function node. This function stores the incoming message.payload in a variable named str. It then replaces the original payload with a new object that has two properties. One property named states that has a fixed value of 0, and another property named text that contains the value of the original payload. The modified message is then passed on to the next node, in this case our UI feedback node. We can use our inject nodes to send a string through this function and out to our UI feedback nodes, and you will see the button text update on the touch panel. If we look at the debug info for this message, you will also notice that the payload contains the two object properties that we mentioned instead of just a single message. In the final example, we are using a change node to accomplish the same thing as the function node did previously. The first rule in the change node sets the value of the states parameter of a flow object named TextObject to a value of 0. The second rule sets the value of the text parameter of the same flow object to the value of the incoming message payload. The third rule sets the value of message.payload to the object of TextObject, the same object we just set the parameters of. It then passes the modified message out to the UI feedback node. We can now use the inject nodes to send messages into this change node and see that our text is updated on our button. That's it for this video. For more news and product information, visit us at our website at amx.com. For troubleshooting tips, FAQs, and code examples, visit our Anytime Help Center at help.harmonpro.com.